So we do the hydrothermal vents first, and then we go back and look at the vertical transects of properties. Here are some observations, temperature and salinity observations in a hydrothermal vent of the Red Sea. Look at the temperature. Look at the temperature. Okay, 30 degrees at the surface. Wow, hey, nice and warm. At 200 meters, there's some parts are left away here. We are already at 2,000 meters, still 20, something like 22 degrees or so. And then the temperature increases to 50 degrees near the bottom in a layer maybe about 100 meters thick. Here you have that layer. Very, very warm. Okay, so you learned about density, and you would think, okay, if it's so warm, then it actually should be very light and just mix over the entire depth, because it would be a convection driven from the bottom, but it doesn't happen. And why it doesn't happen is because it is a brine, very saline water, and that's the salinity here per mil. So you have a 40. Okay, 40 is still above ocean salinities. Typical ocean salinities are something around 35, 34. Yeah, you know that. 40 is higher, it's hypersaline, over a depth of 2,000 meters. Okay, and then getting very, very saline at depth. And it's this high salinity that keeps the water near the bottom. Okay, it has mixed over 100 meters or so. And virtually zero oxygen, no oxygen in that water. You can see that in the dissolved oxygen measurements, which are very low anyway throughout most of the water column, below 2 milliliters per liter, only in the upper 200 meters, just marginally above the critical threshold in order to sustain life. Okay, so let's go and have a look at the temperature, salinity, and oxygen distribution across the Red Sea, along the axis of the Red Sea. Have a look at that. No, wrong way. Go here. Sorry, I keep that in. Mistakes happen. Okay, so Red Sea outflow. Here we are. This is the Red Sea. Temperature on the left, and these are vertical transects. So you have a cake of the Red Sea. You have 3 cakes, a temperature, a salinity, and an oxygen cake. You cut it open, okay? And you look along the axis, 2,000 meters or so, but in order to see something, you squeeze your cake horizontally, squeeze it to a small distance that you can show 3 cakes on one slide. And this is what's done here. You can see warm, all mixed, nice and warm. Okay, the contours are 2 degrees, and all this water is within the 2 degree. Okay? It's well mixed. It's 40 salinity units. Okay, and the oxygen, dissolved oxygen, actually indicates a mechanism that actually mixes water or brings in a little bit of higher oxygen water at depth. You can see something like we call it slope convection. If you remember the lecture from the deep circulation of the slope convection, you can see the signature of water actually moved into the region. Okay? A little bit. It still does not provide enough oxygen to the deep ocean. Okay? You can also see an overflow of hypersaline water into the North Atlantic Ocean. Have a look at that salinity structure. Here, salinity controls the density structure. It's higher density water. That's why it flows over the sill and into the ambient ocean. And there it forms, through mixing, a region which has a locally higher salinity. You can see that 36 region. This is what you can see in the larger scale field observations. This is the outflow from the Red Sea, which actually ends up at a depth of 1,000 meters or so. Okay, Also illustrated here is actually a return flow near the surface. You can see near the surface, 36 comes here near the surface, and then what happens? The salinity increases because through mixing, all that can happen is the salinity increases as the water moves in. Okay, so this is what we call actually, okay, this is an exchange circulation. It is really rather like what we call an inverse estuary. We also see that in the Persian Gulf. Okay, it's a density-driven exchange flow. The flushing time of the entire Red Sea is about 40 years. Very, very long time it takes to actually replace the volume. This is what flushing time is. Okay, so you're given, you know what the inflow is of water. Inflow of water that comes from the Indian Ocean. You know the volume transport associated with this. You know, and if you know, you can work out the entire volume of the Red Sea, and then you work out how long does it take to bring in, to refill the entire Red Sea. Okay, 40 years. All right.